morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about CPU design. CPU is nothing but a Central Processing Unit. So, at the top level of a computer consists of a CPU, that is Central Processing Unit, Memory Unit, Input-Output components with one or more modules of each type. These modules are interconnected in a specific manner to achieve the basic functionality of a computer, that is executing programs. At the top level of a computer system can be described as follows: describing the external behavior of each component, that is the data and the control signals that IARE exchanges with other components, describing the interconnection structure and the controls are required. So what I am saying was CPU is the Central Processing Unit. So, CPU consists of memory unit, control unit and arithmetic logic unit. So, these are the interconnections of this one. So, we are giving input and output. So, between the input and output, the CPU is there. So, CPU is consisting of memory unit, control unit and arithmetic logic unit. So, at the top level of a computer, it is consisting of CPU with input outputs. So, what are the inputs or outputs are there? Suppose I am taking keyboard and mouse. So, these are the inputs. Output is a printer or browser or touchscreen and headphones or earphones. So these are the outputs are there. So these input output components, memory with one or more modules of the each type. These modules are interconnected in a specific manner to achieve the basic functionality of a computer, that is executing programs. At the top level of a computer system can be described as the follows. So these are interconnections: the memory unit, control unit and ALU. These are the interconnections of the ALU of CPU, and these are the describing the external behavior of each component, that is the data and the control signals are IARE exchanges with other components of there. So IARE means instruction register. So these instruction registers are with other components describing the internal construction of a structure of the controls are required. So what is the external behavior of the components? So if I am taking the keyboard, printer, mouse or any of the buzzer or headphones, earphones like this. So what are the interconnections and what are the behavior of a external behavior of a components, that is data and control signals of the instruction registers exchanges with other components, and these are the interconnection structure and the control are required. So we are considering the von Neumann architecture. Some of the basic features of this architecture as follows. So we are following von Neumann architecture. So what is the use? What are the benefits of this architecture? We will discuss now. And what are the basic features of this architecture? First, data and instructions are stored in a single read-write memory. The contents of the memory are addressable by location. Execution occurs in a sequential manner unless explicitly specified from one instruction to the next. So, what we are considering of von Neumann architecture? First one, data and instructions are stored in a single read-write memory. Suppose I am taking register R1. What is the data? Is this one 10 10 10 10. I am taking 8 bit of data. So this data instruction, memory data instruction or memory data register stored in a single read-write memory. So any of the memory, we need memory to store this register. So the contents of the memory are addressable by location. Execution occurs in a sequential manner unless explicitly specified from one instruction to the next. So the execution occurs when I'm going for the move AX, BX, add AX, BX into 03. So I'm executing these instructions or these micro operation with occurs of sequential manner, unless sequentially we are going for one by one or from instruction of the next. So any of the instruction, suppose I'm taking 8-bit of instruction, I need a data instruction to store the read or write memory. So if you are going for the register for read operation or write operation, anything, but I need a data and instruction to store. So R1 is a register. Yes, it is a register with the data of 8-bit. So these instructions are following. Yes, the data is following move AX, BX or rotate left. Suppose I'm taking rotate left of R1. So SHL shift left or R1. So R1 register is shift left operation is going on of R1. What is the data is there? Yes, the data is there, then only shift operation is performed. If there is no data, no need to go for this instruction. So the top level of components are interacted or intersection among them. The CPU exchanges data with memory. For the CPU uses two internal registers. The following is a block diagram of basic computer system is there. So we are going for the CPU design of for memory address, memory data for input and output operations. But here the CPU exchanges the data with memory. For this CPU we need two internal registers or registers we need. Following is a block diagram of basic computer system I'm taking here. PC program counter, IR instruction register, ALU arithmetic logic unit, MAR memory address register, MBR or memory data register, input output branch, controller, input output modules. These are subsystem are connected to the main memory. Instruction 1, instruction 2, instruction 3, that is 0000, 0001, 0010, so on 1111. So it is starting from 0002 to 1111. How many are there? It is a 16 operations are performing, 16 instructions are there. So the CPU exchanges the data with memory. For the CPU uses the two registers to following the basic computer system. So if I am going for the move AX, BX, shift left, AX, BX and add AX, BX into 03. Suppose I am taking this program. So program counter. So program counter means all are related to instructions. Yes, all are related to instructions. Everything is a program. And the program counter means how many lines are there. So program counter will be, it is a PC. Suppose it is a PC plus 1. Suppose it is a PC, then it is called PC plus 1. Suppose it is a PC, it is called PC plus 1. So program counter will count how many lines of data is there. So how many instructions are there in the specific program. And ALU means if the program or micro operation is performed, we need ALU, then it is connecting to the ALU. If we no need, then no need to connect it to ALU. If we need, we can connect it to ALU, then it is going to the controller. If no need means directly it is going to the controller with a specific memory address register. Suppose here I am taking move AX, BX. So AX, BX are registers. So these registers are including data is there. Yes, it is a included data is there. But we need a address. Yes, I need an address for this one. So every register we need a specific data and address. We need a specific data and address for this one. So any of the program, I'm taking 4 lines of instructions are there. Suppose I have 4 micro operation with 4 instructions are there. So program counter will check is the instruction is properly is there. Yes, that it is a properly instructed. Then it is going for the instruction register. So instruction register is finding out the specific instruction is valid or not. Then it is going for the program counter. If the program counter is what is the present loading option. So suppose move AX, BX is there. So it is a loading from BX to AX. Okay, that is called program counter. PC plus 1 means next line is waiting for execution. So move AX, BX is there. It is a PC. Next one is a PC plus 1. Why? Because it is waiting for loading of the next instruction. And ALU. If you need arithmetic logic unit, suppose for the move operation, I no need of any ALU. No need of ALU. So it is not connected to ALU. But add X, BX, shall I need ALU? Yes, I need ALU for arithmetic operations. So it is connected to the arithmetic operation. So every register, I need a address. That is a memory address register. Without address, there is no data. So memory address, memory data is very, very important for the instruction register or any of the operation or instruction or micro operation. It is the input output branch. It is a controller. Controller means all those things will be executing. All the inputs to outputs, what is the process is going on, that is under controller. So controller is a input. It is accepting input and output. In between the input output, PC, IR, ALU, MAR, MDR, all those things are there. So input output modules means if what I gave the input and what I am getting the output. So that is the input and output operation. And it is a system bus in between the ALU operations and between the input and output operations. Here another diagram is there, that is a main memory. So memory address, memory data is there, as everything is a data is there. So where is the data? And for that data is the address is there. Yes, I have the data is there. For this data, I have an address is there. So 000 is the address. Yes, it is the address. So what is the data is there in this? That is some instruction is there. So is this some instruction is there? So what is the address is there? 0001. So how many are there? 1111. Total 16 operations are performed in a specific that one. So it is an instruction or data with a specific address. Instructions are there, data is there. But we need a specific address. Yes, I need a specific address. That is a memory address register. So every memory contains address and data. That is a memory address register and a memory data register. So memory address register which specifies the address for the next read write operation. Memory buffer register MBR which contains the data to be written into memory or receives the data read from memory. Input output buffers, that is IOBR register, is used for exchange of data between the input output modules and the CPU. So already we discussed every memory we need memory address register and memory data register we need. So memory address register which specifies the address of the next read write. Address of the next read write. Move AXBX, add AXBX. So this is the address of the next reader write. Next reader write means suppose the cursor is there, the loading operation is performed here. So MAR means next instruction address. That is a reader write operation. And memory buffer register which contains the data to be written into the memory or receives the data read from memory. Okay. Suppose I am going for the read operation or write operation. Read operation means from memory. Write operation means to the memory. So write means I'm giving the information to the memory. Read means I'm reading the information from the memory. So if reading or writing operation, that is depend on your MAR or MBR, memory buffer register. So if your data is buffering with write operation means from memory the data will become, and it is a read operation means for the memory through the instructions we are displaying, and receives the data means read from memory, to be from memory. And input output buffering. Input output buffering register means used for the exchange of data between an input module and the CPU. So it is CPU input to output. It is an input and output. So between the input to CPU, that is a input buffer register. Suppose for input I am giving keyboard. I'm giving input. Input is a keyboard. I'm giving some information through the keyboard. That is the input to the CPU. So CPU will accept input. CPU will accept only inputs from input side. That is a keyboard or mouse or anything. And it is about the MAR and MBR and buffer registers. Next, a memory module consists of a set of locations defined by sequential numbered addresses. Each location contains a binary number that can be interpreted as either an instruction or data. And input-output modules transfer the data from external devices to the CPU and memory and vice versa. The basic functions of a computer is to be execute a program which consists of a set of instructions stored in the memory. So, a memory module consists of a set of locations defined by the sequentially numbered address. So, any of the memory sequentially addresses are there, including the data. So, what is the data? The data is in the form of binary. So, the locations in the binary number that can be interpreted as each instruction or data. Any of the instruction or data is in the form of binary. So, input-output modules transfer the data from external devices to the CPU. Input to CPU. The data is transferring to the input to CPU. And then it is converting to the output. But the data transfer is mostly in between the input to CPU. The data is transferred from external device. External device means I am going for the some pen drive or memory or CD or floppy or keyboard or mouse. These are the input to the CPU. CPU to, if you need ALU, it is connected to the ALU. If you don't need which, directly it is going to the memory and then going to the output. The basic functions of a computer is to be executed a program which consists of a set of instructions stored in the memory. So, set of instructions is a microprogramming. So, the basic functions of a computer executes a program which consists of a set of instructions stored in a memory. So, the processing required for a single instruction is called an instruction cycle, which consists of instructions fetch and instruction execute. A register called program counter holds the address of the next instruction unless told otherwise. The processor always increments program counter after each instruction fetch so that the instruction is fetched in sequence. The fetched instruction is fetched into a register called instruction register IARE. So, the processing required for the single instruction move AX or shift left of AX or add AX comma BX. Any of the single instruction, one instruction only, is called instruction cycle. So, these are called instruction cycle. So, it consists of instruction fetch and instruction execute. Fetching and executing. First, fetching means it is, where is that? Suppose I gave add x comma bx. So, what I want to add? Some value of ax and some value of bx. So, these values where we are stored? Where is the memory? So, we are fetching. The instructions are properly is there, or the values are these program are saved in your memory as it was saved. Then it is fetching the program, and instruction execution means it will be executing that program. So, the register program called holds the address. The program counter will holds the address of the next instruction. Suppose the cursor is move x comma bx. What is the next one? Shift left. It is called PC. So, what is the address of this one? So, program counter will go for the next instruction. It is ready to execution of the next instruction, and unless told otherwise, the processor always increments program counter after each instruction fetch so that the next instruction is fetched in sequence. The fetched instruction is fetched into a register is called instruction register. So, instruction register IR is tends to the fetched instruction. Fetched means where is the data is stored, where is the address. So, that is a fetched instruction. Means memory address register, then only it will find out the memory data. And it is one example of CPU design with basic instruction cycle of the following. It is a fetch cycle, execution cycle. Fetching means where is the data is there. Start means first where is going on. Fetch next instruction. Execute instruction. Next halt. It is waiting for output. Halt means it is waiting some time for execution. So after that it will get the output. So first one is a fetching, after one executing. fetch is from input to the CPU. Execution means CPU to output. So it is the input side and it is the output side. So fetch next instruction, it is ready for next instruction, that is a program counter. After that, it is executing the whatever given instructions are there, it will be executing and waiting for the output, that is a halt condition. And after fetching an instruction, processor execute the instruction by doing some processing of the data, which may involve arithmetic and logic specifying by the instruction. Then processor writes back the result of memory. These experiment provides a single instruction CPU with built-in controller. A work memory has been provided by checking the working principle of CPU. So any of the input to the CPU, is it related to ALU? Then it is going for the ALU, then memory, then output. If there is no need of any ALU, CPU is connected to the memory. And it is the CPU design. So in the CPU design, it is the input and output. Between the input and output, what is there? CPU is there. In the CPU, control unit, processor means ALU and main memory. So processor means registers and combinational logics. Okay, combinational logic means logical operations. So combinational logic means logical operations, registers, and ALU means arithmetic logic unit. Arithmetic logic operations. ALU for arithmetic logic operations and the logic operations for logic gates means logic operations. Okay, it is the main memory. Already main memory is very important, and the CPU is in between the memory and control. Control unit is memory and data register. It is the output. It is another process of CPU design, input to output, the central processing unit, control unit, arithmetic logic unit. What are the register there? Program counter, accumulator, memory address register, memory data register. Okay, so these are the fetching, means program counter will fetching the next instruction, waiting for next instruction, and it will be going to the program counter to execute. And decode means any of the instruction is converting to the binary and execute. After getting the CPU, it will be executing. And store, the values are stored, the instruction is executed, the control unit updates the necessary registers and flags and reflect the operation result. That could be involves the storing of the result register, updating the program counter for the next instruction. It provides the information about the outcome of the operation, that is a flag, carry flag like this. And repeat means after getting the output from this one and the necessary components, the control unit repeats the process by fetching the next instruction from memory and to increment the program counter to point to the next instruction address and cycle continuously. Fetch, decode, execution. Fetch means from the memory. Decoding means converting to the binary. Execute means we are going for the output. Input to memory and to output. Input to memory and then for output. Fetching, decoding, output. So, input to binary, binary to output, like this also. And the control unit ensures the correct information flow and guides the CPU's action during this process. And it eventually aids the general operation of the computer system, allowing the CPU to carry out the required operations and computations through the fetching, decoding and executing of the instructions. So any of the CPU design, we need a fetching, decoding and executing. Fetching means the instructions are fetching from the memory. Decoding means converting to the binary. Executing means we are getting the output. So the process is in between the input to output. So the control unit, arithmetic logic unit, fetching and stores. RAM means random access memory, or I am taking the ROM also. So fetching means fetching, decoding, executing and storing. So fetching means memory to control unit. Okay, fetching means where is the fetching? The memory. It is fetching from memory, and after the fetching, it is converting to the decoding. Decoding is nothing but a control unit. So control unit is converting to the binary, fetching to decoding. Arithmetic logic unit means we are executing the output through the logic gates or through the arithmetic or logical operations. And store means output. I got the output. Do you want to store or do you want to display through the printer or through the scanner or through the any of the headphones, through the monitor or the whatever it may be, it is the output we are getting. So fetching from memory, decoding from the memory to control unit, arithmetic logic unit to for the execution, and output to store in the memory. Fetching means store memory from memory to is the store. And it is a control unit, address and data. So memory is the data and program, both are there. CPU is nothing but a registers and ALU, both are the important. CPU is under registers, means R1 or 2 like this. So 8-bit or 16-bit depending on the storing of data. And arithmetic logic unit and control unit, these are the CPU. So control bus, address bus, data bus, these are internally connected to the memory and the CPU. So these are the references. So we discussed CPU design. It is the external behavior or component of the data of the control signals, that is the IARE exchange of other components. These are interconnection structure of the control required. We are considering the von Neumann architecture to find out the data and instructions stored in single read-write operation, and the contents of the memory are addressable by the location. Execution occurs in a sequential manner from the memory one instruction to the next one. So it is a top level components and interconnections among them. That is one CPU and memory. So in the CPU, program counter, instruction register, arithmetic logic unit, memory address register, memory buffer register, and input output branch, and a controller input output modules are there. In the main memory, address and data is there. So MAR, MBR, input output buffers are very, very important in the CPU. And it is a fetching and execution. Fetching from input, executing to the output. So it is about the CPU and ALU. It is a CPU components, control unit, processor, memory, main memory, input and output. It is a CPU under control unit, arithmetic logic unit and registers. That means program counter, accumulator, memory address register, memory data register. It is completely the memory unit, input to output. Okay. Fetching means we are fetching from memory. That is a program counter. Decoding means we are converting to the binary of the input values. Executing means after from the ALU. Suppose I give in the A equal to 3, B equal to 4. I need A plus B. Is it executing? Yes, it is executing with the help of ALU. So it is executing of addition of two numbers. Okay. So the final value A equal to 4. I gave A equal to 4, B equal to 3. So what A plus B I need addition. So what is A plus B? 7. Is it stored? Yes, it will be stored in the memory. That is the storing of the output value, storing of the registers, storing of the registers in the form of flags and carry flags at the output. Okay, repeat. This process will be repeat of the components of the control unit by fetching the next instruction from the memory. A plus B completed. Repeat means I need to give another values of A and B. Okay, it is the fetch, decode, executing of the process. Okay, it is the fetching from memory, decoding from control unit, executing to the arithmetic logic unit, and stores in the memory. So data, program, memory, CPU, register, ALU, control bus, address bus, and data bus. Okay, it is about the CPU design. Okay, thank you.
Like, share, and subscribe. Hit the bell icon for more updates.